So in languages like C, C++, the memory management is usually managed by the users itself. Okay, so it is more of a, like you could say, manual memory management. Okay, and whenever there is a manual memory management, it suffers from something which is known as a memory leak. Okay, so memory leak basically means that you have allocated a memory for something. Okay, allocated memory but not freed the same, so that will leave you with memory leaks. Okay, so essentially we have read a lot about memory leaks in multiple articles or things. So today we are going to simulate memory leak, and we'll see tools that could help us to detect the memory leak. Okay, so firstly we'll be writing a simple program, okay, which will actually simulate the memory leak. And for that I will create a new program, test.cpp. okay, and in this program what I am going to do is I am going to manually allocate some memory. Okay, and I'm going to make it free using this thing. Sorry, leak memory. Okay, and for that what I'm going to do is I'm going to create a pointer array here, and this I'm going to allocate over here. Okay, so here if you see carefully, I have used the new keyword. Okay, in CPP we use new for allocation of the memory and delete for deletion of the memory, but here I have not used delete anywhere. Okay, so what I'm going to do is I'm going to simply call this function through my main. Okay, will not do much of an operation over this thing. We'll do just return 0 and we'll call this program, this function, sorry. Okay, so firstly there are two tools basically that will help us. Like one is integrated tool inside the G++ itself, which is the address sanitizer. Okay, so that will help us. It is basically a fast memory detection tool. Okay, that can detect memory leaks, buffer overflows, and set of different kind of issues that you might encounter. So it is both supported in like multiple compilers like GCC and Lang, the popular packages offered across multiple systems, so you can use that. And another package is Valgrind, so it is available on Linux system, I guess. So first you have to install Valgrind. So for that you will have to do sudo apt install Valgrind. And now using Valgrind, before we start using Valgrind, we'll just simply compile this thing along with the debug symbols. Okay, so here I'm going to write G++ -G, which will give me the debug symbols along with the this thing, the object file or thing, that whatever it creates. Okay, and I'm going to say test, and here I'm going to say test.cpp. okay, and we'll compile this thing. Okay, so it has compiled successfully. So now what I'm going to do is I'm going to call Valgrind -leak check. Okay, so leak check equals to full, complete leak check it will do. Okay, and for this we'll have to supply the executable file. So at the runtime this memory allocation occurs. So at runtime you have what you call holes in the memory that you'll have to detect, or leaks in the memory that you'll have to detect. Okay, so we have run this thing, and here you can see we have lost 40 bytes in one block. Okay, so 40 bytes because we have taken an array of integers of size 10, and every integer is 4 bytes. That makes a total of 40 bytes. Okay, so how do you fix this thing? To fix this thing you simply have to write delete and array. you can just simply first recompile it, and now if you run the Valgrind check again, this time it would say all blocks were freed, no leaks are possible. Okay, and here we saw there was like definitely lost 40 bytes in one block. Okay, so this is how memory leaks occur. So as I said earlier, we are having another set of a command that will run. So first let me just clear this thing. Okay, so the address sanitizer comes as an option with G++. Okay, so here you write f -f sanitize, okay, is equals to address, again -g -o test and test dot cpp. Okay, yeah. So now what happens is, when you use address sanitizer, by the end of the program, after the execution of the program, it will show you any possible memory leaks it detected. Okay, so let's just run this thing. So test, see here, so it has detected memory leaks. See here, 40 bytes leaked in one allocation. So here it found the memory leak. Okay, so this memory leak could be avoided by a technique called RAII, okay, which is resource allocation is initialization. Okay, so more about the technique in the next video. So this was just giving you the basic premise of what exactly a memory leak is and how we can detect memory leaks in our program. So whatever programs you write, wherever you're using malloc or say you're using CPP programs where you're using new and delete keywords, so you might run this sanitary checks before you generate a final executable of your program. So this program, this softwares that I have suggested, or the packages debugging things I have suggested, can apply to these two programming languages. Okay, so you can check it out, see how many possible amount of leaks you are able to find. Okay, and see how you can fix it. Okay, yeah, see you in the next video.